Hello everyone, my name is Justin Katz. I work with a company called Schamlz. We're located in Raleigh, North Carolina here in the States. Our headquarters is located in southern Germany. I work as the manager for our vacuum components group in Schamlz along with the engineering and product management. I appreciate everybody having me today and let's get started. So today we're going to talk about what are the various gripping options that are out there for the collaborative robot market. Why choose vacuum? What about vacuum makes it good for handling? What are some of those applications that are good for handling with vacuum? And then kind of getting into a little bit of an understanding of what is vacuum just at a very high level as far as a different type of handling method, some of the vacuum generation types that exist out there from us, and then also what are some of those gripper options? So what do we do when we combine vacuum generators with the rest of the system, meaning the cups or the mounting and things like that, to bring it into a full solution? So what are your gripping options? I want you to think of an example that you maybe had in the past where you had to grip a product and move it from point A to point B. What solutions out there that were in the market did you think of using? Were you aware of all the solutions? Did you consider all the solutions? How were you going to integrate those solutions? These are a number of the questions that we kind of have to think about and stop and ask ourselves, what's going to be the best option for my application? So some of the methods that are out there are what we call ID or OD gripping, so inner diameter or outer diameter gripping. Schmaltz certainly has a couple of these solutions. You can see one here, but what are the advantages and disadvantages of this type of product? We also have magnetic gripping. Magnetic gripping requires a certain material characteristic. And then what about needle gripping? Needle gripping is, by the nature, doesn't sound very collaborative friendly, so maybe it's not the best option where we actually have needles that are coming out. And if we're trying to work near a person or an operator, and we have needles, these sharp devices where we then also have possible pinch points and things like this, these maybe aren't the best solutions, but they could be applied depending on the application. So ID and OD gripping, we see that this is oftentimes used in the assembly and CNC machining. Maybe it's welding or fixturing, and then also soft gripping. So this is kind of an emerging market in terms of the mechanical gripping or OD gripping world. And these are great for foodstuffs and other delicate parts. Many ID and OD grippers offer a high accuracy and degree of precision. They can take pretty high temperatures in harsh environments, but they come with some costs. They come with a high price. They come with high integration costs potentially, and can be somewhat limiting in their application, meaning we have to have a certain amount of clamping area where we can then have the OD gripper, for example, clamp onto. The magnetic grippers, these are going to require ferrous materials. They're going to have an iron content in them. And we see these often being used in the CNC loading and unloading, bin picking potentially with metal parts. They offer a great and highly secure process with a process stability. Our grippers use a rare earth magnet. This is great because if you lose power, we can still hold that part. They're good for repeatable processes because of their precision. They are also maintenance free, but as the name says, with a magnet, you then have to be able to grip something that is magnetic. And therefore we see that it has some pretty limited application use. Absolutely still applicable when we have places where vacuum can maybe not be applied, but in that regard, it still needs to have the ability to be magnetized. Needle gripping, again, these are great if you have a really high porosity level, which also may not be great for vacuum. We see this oftentimes in textiles, fabrics, screens, foams. These are great and very efficient to run. They don't really consume a lot of compressed air, just a couple of simple cylinders that are moving the needles in or out. We do see marking issues with these. Imagine you have a needle penetrating your product. You have to ask yourself, are you okay with this? If you're not okay with this, then maybe we need to find a better means to do this. They're not, again, as I mentioned, the most collaborative friendly devices either. Therefore, we see some limited applications. And then the last is what we're here to talk about today is vacuum. So why use vacuum for handling? Well, when it comes to gripping and moving products, vacuum cups paired with grippers on end of arm tools and vacuum generators are all very versatile means in which many automated handling systems can be done. They come in a variety of types, sizes, geometries, and materials to suit the wide variety of applications that exist. Furthermore, we have a number of other advantages when handling with vacuum over other means of material handling. Vacuum offers a more gentle grip on the workpiece and allows for handling with little to no damage. It offers a simple means of part control via vacuum switches. Moreover, we can use smart vacuum switches that aid in the understanding of the quality of the vacuum our part is experiencing. With condition monitoring, we can visually see the state of the vacuum perhaps. We can also understand where we are in terms of the life cycle of our cups. This gets into topics like predictive maintenance. How great would it be if we could know when that vacuum cup is going to fail? Well, with integrated intelligence and smart monitoring, we can. How do we monitor those things? Well, we have means such as Ethernet IP or IO-Link data, which we can put out to the controller as live information. Moreover, we can go in and easily modify and recalibrate some of our settings. We can do this with a smartphone. We do this via an NFC app. And so this is offering a whole new level of control over the vacuum. Lastly, we can do energy monitoring. Energy monitoring is where we can monitor the amount of compressed air consumed by a pneumatic generator, or perhaps the amount of electricity, or how long a motor is on and to what degree. Last, we see that one vacuum gripper can be used to grip different parts, depending on the application. Because vacuum handles from above, because we're not needing and not bounded by the outer dimensions of a part, such as a mechanical gripper has, that means we can actually employ a single gripper with a grid of cups to handle a whole variety of parts. This offers great advantage when it comes to simplicity of integration. So what applications are best suited for vacuum? Well, we see that gripping with vacuum offers many advantages to a variety of human to robotic applications. So when we look specifically at cobots, when we think about a person and a robot working side by side together, vacuum's very safe and an efficient means of doing that. We see that we can apply this in applications such as pick and place, where we're going to move a part from A to B, packaging and palletizing, where we're going to case pack a product into a case and then perhaps load that onto a pallet. Loading and unloading of CNC machines, where we're going to have parts moving through tasks that were originally done by hand. What about in a lab environment? Quality and control testing, where long cycle times are needed to move products in and around. Now we can employ the person to go do other value-added tasks. Assembly, where we have to put a part precisely into a hole, for example. So this is where robots are very good. The level of repeatability and precision, coupled with a very precise placement of vacuum with a very secure hold, can do that job very well. What about randomized bin picking? Well, when we have the ability to handle from above, such as with vacuum, maybe we have limited room to engage a part, coupled with a vision system, we see more advantages in bin picking than we ever had before. And in that vision system, Schamlz is offering also complete solutions where we integrate not just the vision system, but we are already pairing that with a provided vacuum generator extension as well as vacuum cup to do some of those jobs, which can of course be customized to an individual application as needed. So let's take a quick step back and just quickly understand what is vacuum in a very, very simple term. Vacuum is the term for air pressures which lie below normal atmospheric pressure. So imagine, if you will, we have a workpiece that we're engaging, as shown here. We have a vacuum cup that comes down, and we evacuate the pressure, which is currently at atmosphere, to an under pressure, to an air pressure below atmospheric pressure. What this means is that for vacuum handling to occur, we actually see that it's atmospheric pressure all around the top of the cup, as well as anywhere that the workpiece is being influenced by that vacuum. The atmospheric pressure is actually causing these two components to come together. It's a pretty unique aspect in understanding that we're not really mechanically gripping this device in any way, and that it's truly one of the most gentle forms because we have vacuum inside the cup, and then we have pressure pushing everywhere else. So this is really what leads to gentle handling with vacuum. And we see that with this, pick and place assembly and material handling will account for 75% of cobot applications over the next 5 years. Now, this is just our understanding of it, so maybe you've seen or heard something a little bit different, but that means Of that amount, some portion of that will be vacuum. And some with that, so about 20% of all cobot application work by means of vacuum gripping technology. And of course, our job is to see this to be successful and also try to increase this amount. So what are some sources for vacuum generation? How do we create vacuum? So we'll start with electric vacuum generators. Let's say that you want to handle airtight parts such as plastic or metal, and you want to move your robot to different places in your facility. These units allow you to do that. They create smart vacuum without compressed air. All you need is a place to plug in your robot, and you can begin to work. They can handle up to 10 kilograms or about 22 pounds. Let's first look at our ECBPI. The ECBPI is great for airtight or slightly porous workpieces. It's great for mobile material handling. You can see here it's got rounded corners and soft touch edges and bumpers. It's got integrated smartphone control via the NFC function. It's got IO-Link, which allows us to watch and monitor the status of the unit live. We can also monitor the status of the unit on the onboard display. What you see here is a kit that we offer, which comes with everything you need out of the box to get up and running with your UR robot. We have the flange, the electric pump, cable, various cups, as well as a plug-in UR cap on the USB stick. Next, we have our Smart Electric Cobot Pump Mini. This is the miniature version of this device. It's about a fourth of the airflow and certainly a lower payload, but it is great for small, low weight, and airtight workpieces. It's got a tiny profile. It's the same diameter as the UR wrist. This allows it to pass into very small areas and spaces, which may be great, as we mentioned earlier, for a lab environment. This pairs nicely with the smallest at 3 kg, as well as up to the largest, 10 kg. Even though it has a payload less than kg, perhaps we need the larger robot for its reach. Next, it has integrated IO-Link and RS-485 Ethernet as well. It has an integrated LED light ring that flashes from green to orange, which allows for at-distance visual monitoring. You can see that we offer a kit for this as well. It offers the unit with integrated cable, as well as a couple of cup options. All of these can, of course, be adapted to your application with various tooling designs. Here you can see our vacuum end effector or VEE tooling, which is a configurable tooling concept. You can also pair your own custom grippers on these devices. So what happens when we still only need one or a few cups, but our product is too porous for our ECBPI or ECBPMI, as when handling cardboard? Or what if we need to handle a product with quite a few more cups because we need more holding force and we need those cups evacuated quickly? That's where our pneumatic RECB vacuum generator comes in. With the same familiar controls, simply load the UR cap, configure the Schamlz VEE or your own desired custom tooling, run your compressed air hose, and begin to work. This smart pneumatic cobot pump is great for airtight or highly porous and uneven workpieces. It can also handle non-rigid workpieces such as filled cartons. It offers an intelligent I/O interface as well as IO-Link interface. You can see here we offer this unit also as a kit. It comes with the flange, a cup option, as well as the run of compressed air hose to get you up and running. Another recently approved product from Schamlz in the UR Plus program is our SCG HSS flow gripper. This unit is great for picking highly structured surfaces. It offers point of use, high flow, low vacuum. So we have to ask ourselves, well, where do we see highly structured surfaces? It could be an injection molded part that maybe has a very irregular shape that we need to bin pick. But moreover, we oftentimes see this device used when handling populated circuit boards. So in the past, we would maybe have to have some very small discrete cups that handle on a very smooth area. But imagine now being able to deploy a robot very quickly, have this gripper from Schamlz, the SCG HSS, and have it automatically adapt to a part every time. So even if there's a little bit of a change in your workpiece from part to part, we can see that the gripper can adapt and compensate and offer very delicate and gentle handling, but very reliable and secure handling. As a bonus, it's also ESD compliant, which allows us to safely ground the device and ensure that we are not causing any damage, either immediate or latent, to the circuit board. We've now covered a variety of the vacuum generators that we have that are collaborative robot ready. But what about turnkey grippers? What type of grippers can we offer that allow us to get to work right away in handling a very wide variety of parts? Let's begin with our bin picking gripper. The Schamlz bin picking gripper, or SPPG, allows for complex picking out of bins and totes. It's a gripper with an integrated vacuum generation as well as vacuum monitoring. Yes, that same intelligent vacuum monitoring we talked about before. It also can be supplied with an external source if desired. Its slim, elongated design is great for reaching into those bins and totes. We then pair and couple that with an adept and flexible suction cup, which is great for gripping, even on corners and edges. Moreover, we can also add the fact that we have a swivel module, which can save time on the robot's movement. Imagine you need to come in, and in order to pick that part, you needed to approach at an extreme angle. Well, by having this swivel module, you can then actuate it pneumatically, and it allows you to approach much easier. Here you can see the unit mounted on a UR robot. We are picking up on a very complex shape. We're able to handle a cylinder from the end using this very unique and adaptable cup. Next, we have configurable grippers. What is a configurable gripper? It's just that, a gripper that you, as the user, can configure directly on our website. It's a lightweight gripping system, or our SLG. It's configurable by the customer. It means that they can take their own parameters of their application, input it into our tool, and instead of designing, we configure. Imagine you can upload a 3D model of your part in STL format. You can then have it appear in the configuration tool, and you can select the exact placement of vacuum cups around your part, and the vacuum gripping tool is built to your part. This is great for custom solutions to 3D shapes. It's great if we need to handle a flat surface, but what happens when we have a 3D shape? That's where the Schamlz lightweight gripping system comes into play. We do have to make sure we are mindful of the payload capacity of this device. This can vary based on acceleration, but in general, we can handle most applications that would be suitable for a collaborative robot. Additionally, we do this, and because it's additive manufacturing, we can deliver very quickly, generally much faster than a custom designed end-of-arm tool. Last, we can pair this with the Schamlz Cobot vacuum generators we've already discussed. You can see here we have our ECBPMI, which, if you recall, was our low flow device. And so what this means is we have a very compact generator that allows us to pick this airtight part very reliably, as well as the fact that it's completely adapted to this particular workpiece. We've now talked about single cup handling with our bin picking gripper, for example, or custom configured and specifically located cups on our SLG 3D printed gripper. But what happens when you have a large variety of parts or boxes to handle on a single line or around your facility? Area grippers offer a versatile solution. The ability to have uncovered cups and still have ample holding force makes picking and palletizing easy. Because vacuum grips from the top, little to no clearance is needed to then place boxes and or parts side by side. With our area gripping systems, in this case our FXCB and FMCB, it's great for handling products regardless of size and geometry. You can get the unit in foam, great for rigid products, for example, or cups, good for flexible products such as cardboard. It's got a relatively low weight, so we're not consuming the payload of the robot with the end-of-arm tool. Its rounded shape makes it perfect for collaborative use. It's typically used for these palletizing and depalletizing applications. Options for integrated or external vacuum generation can be chosen at the time of selection. Here you can see our area gripper FXCB handling boxes. This unit has a very small, discrete, compressed air line coming down to the gripper to supply the integrated venturis. It then has onboard valve control as well as vacuum monitoring. Here we see our next generation of area grippers with even more capability. The concepts are the same, but we offer a whole new variety of holding forces, sizes, and performance options with this unit. You can still get it with foam or cups. It's again going to be used for general pick and place on our smaller units, as well as that end-of-line palletizing that we talked about. It's also got integrated pneumatic vacuum generation available, or a connection for external vacuum generation. Here you can see the three size options of the FQE series, from a small, medium to large. As you can see, Schamlz offers a wide breadth of solutions that can benefit anyone who's looking to do material handling with a universal robot. All the products shown here are UR Plus components and offer a varying level of smart functionality based on your needs. And the best news is there's more coming. I really appreciate your time today, and if you have any questions, I'd be happy to answer them. With its solutions, Schamlz contributes to the goal that everyone can put cobot systems into operations quickly and easily. Thank you.